Dear students, today we will learn a new module, weighted arithmetic mean. So here you have to remember that weighted arithmetic mean meaning we are giving certain importance for other items which is relevant to the data. That is the simple meaning of weighted arithmetic mean. I am going to explain with the help of an example. So in the computation of arithmetic mean, we are giving equal importance to each observation in the series. Say for example, if you are taking the household expenses of 4 houses, one you are getting 2400, second one you are getting 3600, 5800 and 6800. If you take the mean, you take the total of these 4 household expenses, that is 18600 divided by 4, you will get 4650. But if you give importance for the number of members in the family, imagine the first house has got 2 members, second house 3, third house 4 and fourth house 6 members. So total members in the family 15. Now if you are using weighted arithmetic mean, what we have to do? Wx, the weights, the number of members in the family we are denoting by W and the individual observations are x. So Wx, if you take the total 2400 into 2, 4800, 3600 into 3, 10800, 5800 into 4, 23,200, 6800 into 6, 40,800. So sigma Wx is equal to 79,600 divided by 15, the total number of members in all the 4 houses. So your average we are getting as 5306.67. So now from this example it's clear that giving equal importance for each information is misleading. So if the individual values constituting the series has got different importance. See in our example, number of members is an important factor in our calculation. So when you are doing weighted arithmetic mean, we are giving importance for that information and that will be helpful in the computation. And uses of weighted arithmetic mean. So uses of weighted arithmetic mean we are using for doing the problems also. So it is useful to compute mean of means. One problem if I'll explain, arithmetic mean of daily wages of A limited and B limited are 45 and 50 respectively. Number of workers in both the concerns are 2000 and 4000 respectively. Compute the average wage of both the concerns. So first column we are showing the mean values of two groups, 45 and 50. Second column, number of workers, 2000 and 4000, total is 6000. Now Wx, the weight you are giving, that is the importance, the number of workers in each factory. So 90,000, 2 lakh and total you are getting 2,90,000. So if you take the combined mean, 2,90,000 divided by 6000, it is 48,33. Now uses of weighted arithmetic mean. Second point, if you see the second use of weighted arithmetic mean. Weighted arithmetic mean is used to describe the mean of percentages. So first advantage we have learned, now the second one. One problem, admissions during 2020 to 2 colleges increased by 20% and 40% respectively compared to that of 2019. So if the admission in 2019 were 800 and 200 respectively, find the mean increase in the admission of 2 colleges. This information will be helpful for the universities or colleges for taking their decisions regarding admissions. So we can calculate using the weighted arithmetic mean. So A and B, 2019 800 and 200. Percentage increase is 20 and 40. So 2020 the admission is 800 plus 800 into 20 by 100. So it's 960 students. Second college, 200 into 40 by 100, 80 plus 200. So that is 280. So when you are taking the total, 2020 admission is 960 plus 280, that is equal to 1240. So now you can calculate the percentage increase. 1240 divided by 1000, that is 800 plus 200 into 100. So 124 minus 100. Percentage increase. So you have to subtract 100. So you are getting percentage increase as 24%. Now one more problem. A student gets the following percentage of marks in BCom examination. English 80%, Hindi 70%, accountancy 60%, costing 70% and statistics 50%. Find the weighted mean if the weighted means are 1, 1, 3, 2 and 3 respectively. Now here also we can use the weighted arithmetic mean for computation. So the subjects are there and the values, corresponding values are there, and the weights are also there. When you are taking the sigma fx total, you are getting 620. So 620 divided by the weights for the various subjects is 10. So 620 divided by 10, that is equal to 62%. That is the average marks scored by a student. So as students, we will also calculate the marks scored by the students. So this is how you calculate the percentage of marks scored by a student for different subjects, giving different weights for each subject. Now we will see what are the merits of arithmetic mean. It's simple to understand and easy to compute. There are three series: individual observations, frequency distribution, and group frequency distribution, and simple calculation. Especially when you are using step deviation, it's very simple. So second point is you have to remember the case of median. You have to arrange the data in ascending or descending order. Similarly, if you are doing mode computation, you have to group the data. So these two arrangements are not needed if you are using arithmetic mean. Computation, as it is the frequency distribution or the individual observation, you can directly use the equation and you can compute the values. Now computation is based on each and every item. In the case of mode, we will avoid certain values. There it is not possible. In the case of arithmetic mean, all the values are used throughout the computation. Now fourth point is it's well defined. It has got actual equations for computation and all the equations that they are using, and it's well defined. Now capable of further algebraic treatment or statistical computation or mathematical treatment in regression, coefficients, QNS, we will use arithmetic mean. Now it's not affected by sampling fluctuations. So if sampling fluctuations are there, that is not going to affect the data. If you are arranging the data or if you are grouping the data, sampling fluctuations may affect the results. Since it's not doing in the case of arithmetic mean, this will not affect the result. Now mean is the center of gravity, thereby balancing the values on either side of it. When we are taking mid values for computation for a group frequency distribution, we assume that equal number of values are below the midpoint and equal number of values are above the midpoint. So this is the feature and it's an advantage for arithmetic mean. So mean is a computed value and not based on position as in the case of median or mode. Now if you see the demerits of mean, if you have advantages, it will automatically have demerits or limitations also. The value of mean is affected by extreme items. For example, mean of values 10, 20, 30, 40 and 50. That is equal to 30. That is equal to total 150 divided by 5. Individual observations, take the total of the values. You will get 150 divided by 5. So the mean is 30. But if you are adding one value, one extreme value from the observation, that is 100. So your mean value will change to 250 divided by 6. That is equal to 41.67. The third limitation is in the case of open-ended series, value of mean we cannot compute without making assumptions regarding the missing value. Maybe it's the lower limit of the series or the upper limit of the last class, or whichever class is not defined. We will assume that it is uniformly distributed. Whatever the assumption we are making, based on that we are doing the computation. So that is a limitation of mean. The fourth point is arithmetic mean is not a good measure of central tendency. For example, asymmetrical distribution. Asymmetrical distribution meaning frequencies are not evenly distributed. We say that when you form a bell-shaped curve, if the frequencies are asymmetric distribution, that meaning see the example what I have used. 4 values we are getting mean as 30. But if you are using one extreme value as 100, then the mean is changing. So mean is not a good measure of central tendency for asymmetrical distributions. So this is what I want to explain with this module. Thank you.